Hey everybody, this is Larry. This is me go over Q4 of the Biweekly Contest 101, shortest cycle in a graph. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. So there probably is many ways to solve this problem. The way that I actually thought about it, I mean, there's a lot of just graph theory stuff in general. So I was actually, during the contest, I got a little bit confused and I thought I could do it in one cycle of Bellman-Ford. But I was wrong, is the short answer. Or because I really thought that, maybe one thing to know is that E is actually only 1,000, right? So maybe you could do V times E was what my thought about this particular problem. And for V times Z, I could do Bellman-Ford, but it wasn't even necessary because the rates are 1, right? So actually a more standard breadth first search was good enough, and that's basically the way that I did this problem. I think I just complicated things a little bit too much because initially I also tried to do Dijkstra, and that also was just too slow, so I didn't actually fully implement it. For the Bellman-Ford, I just missed the factor of V's the way that I wrote it. So yeah, and I think even my Bellman-Ford was also incorrect, but I had a minor thing that I had to fix, but I didn't, which I did in the breakfast search. But yeah, okay. So basically, the idea behind this problem is just really brute force using every node as the starting point. I am pulling up the drawing utensils. Hang on. But basically the idea is that, okay, let's say you have a graph, right? You have a graph that looks something like, say, this. Oops. Right? And then, I mean, there could be other components, but that's not really the interesting part here, right? The idea here is that, okay, let's say we root this in, let's say we start here, right? We're trying to figure out basically the smallest cycle that includes this node, and basically my breadth first search is that I'm just going do right, and well that right side doesn't matter, but the idea here is that for every edge we examine, we go, okay, well, if we could go back to a previous node, let's say there's an additional edge that goes here for some reason, and it could be in either direction, right? It doesn't really matter which way you parse it. Though I guess, if you do a breadth first search, it'll go the other way. But basically you're saying, okay, now this creates a cycle. If you're able to see it, that means that here, it is just the length of the path to here plus 1 for the middle thing. And that would be how you calculate a cycle. That's basically the idea. I think the thing that I was debugging for a little while as well is just that you have to prevent 2 cycles, which is kind of obvious because otherwise it's just it's non-trivial, or it's trivially true for any edge really, right? So for that you just have to keep track of the parent, so that basically you go, okay, well, we came from this way, so as long as we go from anything not that direction, then we're good. So that's basically the idea that I put this problem, and we'll go over the code now, right? So we set up the edge list, and basically here, it's just a breadth first search. Set up the distance for the breadth first search, set up a queue, set up the parents, and this is just a regular breadth first search. If we are able to get here from a new shortest path, we set the parent to the the relaxing node. We add it to the queue, and then otherwise we have an edge. That means that if this is not true, meaning that this is not a shortest path, a new shortest path, that means that there's an edge that connects 2 nodes that we have already seen, and all we have to do now is just make sure that they're not the parent of each other, and then you do a min based off that because that's the length of the cycle. If you can't find a cycle, it's -1. Otherwise, you set up, you return the best, and that's pretty much it. what's the complexity here? This is actually also v times y, because this is the v component, and this is also O of y. I mean, you can also say this is O of v plus e, which, so it's maybe v times v plus e if you want to say it that way, which is probably true as well because we accept the parent and the distance away. So yeah, so this is going to be O of v squared plus v time, oops, caps lock. And for space, this is just O of v plus e. Cool. Making it slightly smaller so you could see everything. But that's all I have for this one. Let me know if you have any confusions about it. I think it's kind of, I mean, it's also one of those problems where, yeah, I don't know. It's kind of tricky to kind of, because it sounds so simple, to be honest. I feel like I probably have done this problem before, and I think that kind of worked against me for this particular one, because I feel like, and I probably have, but I don't remember. But like I was like, oh, this is simple, straightforward enough that I have done this, so it must be these things. And then I just couldn't like get around being like, Larry, stop trying to remember the solution, and stop trying to get fancy, and try to just actually solve the problem. And then when I finally focus on like, okay, maybe I've seen it, I don't remember it, let's focus on solving it, and then I did, I guess. I did take a little bit extra time because I just didn't think about the parents part, so I was getting twos for everything for maybe good reason. But yeah, anyway, that's all I have for this one. Let me know what you think, and you could watch me solve it live during the contest. Now, this one has more accepted. Let's do this one first then. Even if people are doing backwards. Okay. Do I know this one? There are only 1,000 edges. What is this called? Okay, maybe I just don't know anything today. Okay. Almost don't remember Bellman Ford anymore. I guess I don't need this. Do it the other way too. Oops. That's not right, is it? Oh, this isn't quite right. Wait, that's not right then, right? That's too slow to do a Bellman Ford on. Isn't that E square? Well, let's see if it's right. Okay, it's still wrong, so that's gonna be not Gucci anyway. Isn't it Bellman Ford? No, but this is kind of weird. I think this only works for maybe. Okay. I don't know which one to do, but either way, people have finished, so. Because basically you relaxed every time you get this, but. Maybe this isn't quite right. I could do Bellman Ford, but. Maybe I could try Dijkstra. I forgot about this factor for some reason. I feel like I think this works for one thing, but Well, that's nice, but definitely not updated. 56 people got this one. Well, today's just not my day, I guess, for these ones. But I don't know why I'm so bad today. My graph algorithms are not good. All right, let me go back to here. Maybe I can actually do it. Well, people got this one more, I guess. I should have done this one first. It's dice true. I think I got confused with trying to think too much. Nope. Keep on getting these pop-ups. That was... that's not right. Right. Is this one indexed? No. Well, we don't do anything. Why don't we do anything, Larry? 2, 2. Oh, I think I got confused on the. I mean, that was too slow anyway. But I think this should be this plus 1. So that's the number of nodes, and then what to count. Why is this returning 3? So 1. 0, 0, 1. So it's going back. Okay, so we have to do something like keep track of a parent or something. If something like that, right? Oh, then maybe we don't need the plus 1. I sometimes it's like the number of nodes instead of the other thing. That's why it's a little bit hard. Do I have another print? Nope. Is this right? Let's give it submit. Okay, it is fast enough. Don't know how to do this. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem or this contest and everything in between. How did you enjoy it? Yeah, that's all I have. So stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.